All right. What we're going to talk about right now is vertical transformations and horizontal transformations. When we talked about in the previous tutorials that whenever you have a transformation, you are changing the points. And with a vertical transformation, you are actually changing of your ordered pairs. You are changing the y value because vertical refers to the vertical axis, and our vertical axis is the y-axis, and so we're changing those values. Now, all the inputs inside here, all right, that we have on this particular function, we'll use this as our example. All right, and we're going to take this data set of points of these count points. So we have this point, this point, this point, this point, and I put them right here in this little grid. Okay, and as we go through and identify these different transformations, what we're going to do is we're going to realize what is happening. So as I plug in a 0 into this function, I get a 0 and I get out originally a -1. However, in this case, I am multiplying this -1 by 2, so I have -2. All right, I do the same thing. I plug in a 1. Originally, I get out a 0, but that 0 times 2 is going to turn to 0. And then I plug in a 3. And when I plug in a 3, I get out a 1. 1 times 2 is going to be 2. And then what happens is when I plug in a 4, I get out 2. And so I have, multiply that by 2, I get 4. So each one of these, what I'm doing is I'm taking the x value to get my y. I'm taking the x value that I plug in, all right, and I take my output of that x value. And so in this case, to get this value, I took the 2 right here, 2 times my output, I get -1. Right here, I took 2 times 0, and I got 0, and I took 2 times 1, and I got 2, and this is 2 times 2. From here, we can plot these points 0, -2, 0, -2, we have 1, 0, we have 3, 2, 3, 2, and we have 4, 4. And I'll put a 4 up here, and we get that. That's la la, and we have our value. Now what you notice is this is what's called a vertical stretch. Because we multiplied by this value, this a value right here, which is greater than 1, we actually took all of our y values and stretched them. We made them larger. Okay? We could do the same thing by doing with our vertical shrink. If we have a multiplier outside of our function, we do the same process, except now, as I plug in my x values, I notice that all my y values would be going down by 1/4. So this would be -1/2. This would be 0 again. This would be 1/2, and this would be 1. All right? So as we go through, and we can plot these points, we have 0, -1/2 right here. And we have 1, 0, and 3, 1/2, and then 4, 1. Okay, and you can see that when we plot these, it's shrunk. It's actually made smaller because all our y values have been multiplied by 1/4. All right, which made the y values shrink. Okay. Well, we can also do that with the horizontal. Okay, with horizontal, when we have a horizontal shrink or stretch, what we notice is that we are changing the inputs. So we're multiplying the x's by certain values. All right. Now, when we think about this, we once again have the ordered pairs, which are the same from our same function. But what happens is when we change or shrink or stretch our x values or our domain, horizontal transformations, is that it kind of changes the opposite. Because we started with 0, and I guess we'll get to 0. We can plug in 0, so that'll be just 0. We plug in 0, we get a value of 0 for our input, so we get -1. All right. Now the next thing is we have to get 1. So we have to think to ourselves, what do I have to plug into here to get 1? Well, you notice that if I plugged in 1/2 in for x, what I would have is 1/2 times 2. And right here, then I would have f of 2 times 1/2, which gives me f of 1, which we know f of 1 from our original function equals 0. Then right here, if I have this right here, if I multiply by this by 3/2, all right, 3/2, so 3/2, f of 2 times 3/2, you notice that 3 will cancel out with 3, and we're left with 1 again. 2, and we can do the same thing, 2. But you notice that all of our x values, we are actually dividing by 2. So you actually can figure this out by taking all your x values and simply dividing by 2 from your original, all right? So we're taking the reciprocal of this. So it's the opposite of what we think it's going to be. All right, and we plug in the 2, and we have 2 right here. So we can graph this. We have 0, -1, point, color, 0, -1 here, and then we have 1/2, and that's going to be 0. And then we have 3/2, which is right there, which can be 1. And we notice we have 2, 2 right there. So our y values didn't change, but our horizontal shrink actually condensed it or brought together this original function, right? Made it skinnier. Well, in the same way, when we have a horizontal stretch, this would be a horizontal stretch. Even though we're multiplying by 1/3, I plug in 0. Well, 0 is pretty easy. Plug in 0, you get 0, it's -1. But 1, what do I have to get back to 1? Okay, well, in order to get equal to 1, I have 1/3 times x, multiply both sides by 3. Oh, so I need to plug in 3 for x, all right, this value right here, all right, and we solve that in order to get my value, okay, because 3 times 1/3 gives me 1, which gives me the value I need. 3 times 3, that gives me the 1 I need, which again is that one right there, okay, because of the original input, I get 0. And what you notice is a little pattern. I just multiply all my x values by 3. So then I have 9, and this one's going to be 12. And each one I do that, I get the corresponding value I would need. All right, so I plug in 9 into here, and I get 3. 3 gives me 1. I plug in 12 in there, it gives me 4, which gives me 2. I can plot this up here, and what you'll notice is it gets longer. I just do a couple of them right here, and then we have 3 and 0. You got that one. And then I'm running out of room. So this is one is way over there. But you can notice that this is getting larger. We actually stretched out a graph quite a bit. All right, over there. Okay. So that is how you can identify or work with horizontal stretches and shrinks, and also vertical stretches and shrinks, which are all transformations. I hope this helps. Just remember that every graph has points, and you're transforming those points either vertically, you're messing with the x, messing with the y, or you're messing with the x values, all right, when they're horizontal. All right, enjoy.